So let's move right on and talk about how the weakest precondition for the if command is defined. Here we have the if command, but now we have annotated it with a postcondition R and with the weakest precondition for which we would like to determine a definition. Now, what do we know? If an arbitrary statement here is chosen to be executed, then it must put us in a state where R is true. Either a statement is not chosen, and it doesn't matter what state you end up in then, but if a guard is true, then the statement associated with it must complete in a state where R is true. Now, what else do we know? Well, we know that if a command or statement is executed and is to leave us in a state where R is true, then we must be in a state where the weakest precondition is true. So we know that just before a typical statement, the weakest precondition of that statement leaving us in a state where R is true must be true. And this now sets us up to define what the weakest precondition of the if command is. Okay. First of all, one of the guards must be true. That's the G0 or G1 or and so forth all the way up to GK minus 1. And then if we look at an arbitrary guarded statement, G1 in this particular case, guarding S1, then notice that if G1 is true, then we better be in a situation where the weakest precondition of S1R is true, because otherwise executing S1 will not leave us in a state where R is true. And what we have just done is justify how the weakest precondition for an if command is defined. So let's look at an example in how we may prove a code segment correct using this definition. So here we have a code segment that assigns to variable z the absolute value of x. What does that mean? Well, if x is greater than or equal to 0, then z is equal to x. If x is less than or equal to 0, then z is equal to minus x. And one thing that we notice is that both guards might be true at the same time, because if x is equal to 0, then both are true, and therefore we don't know which of the two guarded commands actually is executed. But what we do know is that we still end up with z being the absolute value of x, because if x is 0, then whether you set z equal to x or minus x doesn't matter. Either way, it ends up being equal to 0. So the question now is this a correct code segment? Well, what do we do? Well, we know that the precondition Q must imply the weakest precondition. We notice that the precondition is just true, and therefore we know that the weakest precondition actually has to be true if this code segment is to be correct. So here's the code segment again. We now look at the weakest precondition. We outline what it equals. We only have two guards, so we only have G0 or G1, and then if G0 holds, then that has to imply the weakest precondition of S0R, and if G1 holds, then that has to imply the weakest precondition of S1R. Then we can simply fill in what the guards are, and we can fill in that the first guard must imply the weakest precondition of the first statement, and the second guard must imply the weakest precondition of the second statement. It's a matter of just filling it in. So that puts us in this situation, and now we notice that we have learned how to compute the weakest precondition of an assignment. So that allows us to get to this point right here. What else do we know? Well, we know that x greater than or equal to 0 or x less than or equal to 0 evaluates to true. We're going to be a little bit sloppy, and we're just going to talk through the fact that if x is greater than or equal to 0, then that implies that x is equal to the absolute value of x, so that gives us the second true. And finally, if x is less than or equal to 0, then that implies that minus x is equal to the absolute value of x, and that gives us our third true. And if we then apply AND simplification, we just end up with true. So what do we know? We know that this code segment is correct because we proved that it is correct.